Welcome everyone to the Szertár Podcast episode 196. And this is also the second episode of a mini-series called COVID Conversations. It's a series I do in collaboration with British Council Hungary. And I would like to say a big thank you to the Embassy of the United Kingdom here in Budapest for making this series possible. And yes, as you can hear, it will be in English because my guest today is from the United Kingdom. If I wanted to give you an official introduction, I would say that he's the science director of the Science Museum or Science Museum Group in London, and he's also a member of the Medical Research Council in the UK. But he's also an author of many books, such as The Physics of Christmas or The Science of Harry Potter. So I'm sure this will be a very interesting 1 hour long conversation. Please welcome Roger Highfield, who is
Hi,
here
Leslie.
with us. Hi. I know you are very proud of something, and although it's not part of this COVID conversation problem here, but you can find this information everywhere in your CV, on the bio of all your social media platforms, that you were the very first person who bounced a neutron off a soap bubble. Can you just explain us in a few sentences what that really means?
Well, it was a long time ago. I was at Oxford University, and I was one of many people fighting for beam time on an international facility, the Institut La Langevin in Grenoble, which is basically a nuclear reactor with holes in the side of it. Beams of neutrons would come out. And I was doing a doctoral project with Oxford and also with Unilever, who makes soap. And what we were interested in was the very fundamental properties of soap films, which are kind of related in a way to the membranes around your cells in your body. And actually, if you watch a soap film thin down, you can see these beautiful colors, caused by the light. Rather like if you see a slick of oil on a pond, you can see different colors, and different colors are different thicknesses. But what's really interesting about a soap film is that if you let it really thin down to just a few molecules across, it goes invisible. So you can see the meniscus, you can see where the water's coming up to the soap film, but you can't see anything above it. It's completely invisible. It's so thin, it's thinner than the wavelength of light. So you've got to use other ways to measure that distance, and that's where the neutrons came in. And so I was bouncing neutrons off that soap film and seeing the interference effects is a lovely example of wave particle duality. And I could actually measure the thickness of the soap film. And I used heavy water soap films, and I also used heavy soap. That's where you swap hydrogen for deuterium. So this soap was worth more per gram than gold. And that was a way of just measuring these ultra thin films. So it's this technique's still in use today, but I was one of the very first people on the planet to use it. So again, just for investigating ultra thin films. So it was useful, Laszlo. It wasn't just a mad English scientist thing. Don't worry.
Yeah, because I explained to you what British scientist means in Hungarian terminology. It's someone who does improbable research, so pretty much ignoble for everyday life. I'm not sure how to put it nicely, but it will be very difficult for me to connect to today's conversation topic, which is collecting pandemics or collecting COVID specifically. You work in the Science Museum in London. You're the science director. If I think of museums and if I think of COVID, probably the first thing that comes to my mind is, okay, there is a lockdown, museums should be shut off, and there will be a financial problem in this sector. But some museums, like you, saw an opportunity in this problem, or what happened? How did you start this whole project? If you could tell a few words about that.
Yeah, sure. I have to say, sadly, we are shut today. There's a new lockdown, a slightly softer lockdown in the UK at the moment, and it is causing all sorts of impact on our income and so on. But the thing about the Science Museum Group is we have the best, probably one of the best medicine collections on the planet, the Wellcome Collection. We've probably got one of the biggest medicine galleries on the planet as well. which is pretty much the whole first floor of the Science Museum in London. And we've got a big curatorial team, medical team, who were really interested in capturing what has to be, the biggest health crisis of a generation. And the problem with collecting around it is there are so many dimensions to COVID, and it goes everywhere from trying
Absolutely.
to collect the face masks, collecting some of the ventilators that have been made, collecting some of the machinery, like these little minion devices that they're using to read the genetic code of the virus, even the artistic response to it, and more difficult, the cultural response, the big hospitals that have been set up, the big labs that have been set up. We're trying to look at it in many different ways.
Isn't it too early to start to collect information? Like, how can you filter what will be useful in the future and what not? Because we are right in the middle of this pandemic, so maybe it's very hard to curate such an exhibition.
I think that's a really good point. And there are some things that are kind of obvious. So, for example, we've collected some of the signs used by the government, including the ones on the podium of the Prime Minister, because people would recognize them instantly. Some other things are, you're absolutely right. We'll only recognize
this
them.
sign thing is similar to that keep calm. I think it was very stereotypical British thing that was in the Second World War, I think.
Yeah, sort of. That's right. Simple messages to help the public understand what was going on. But the thing that we found often is when you collect around science, I think one of the museum people love what they call material culture, and it can take many forms, and it could be something that a scientist doesn't really value at the time. So although I half agree with you that often you only realize how important something is years down the event, years after the event, and maybe it could be something very big and obvious, like, this was the vaccine that ended up being mass produced and saved the world. But there are little things that are thrown away that will be lost unless we collect them today. They could be the notes made by a scientist, recording the first trial of what turned out to be a vaccine. And they might have just chucked some notes away or some doodles to show things to colleagues and so on. I mean, I'll give you a slightly mad example. When the Rosetta probe landed on a comet, this was a funny shaped comet. It was like two comets squished together, and it looked like a rubber duck. And the lander team actually bought a rubber duck, and they were using ballpoint pen to mark on it the possible landing sites for the lander. So we have the rubber duck, and we're really pleased to have that. And that's the kind of thing that could have been thrown away, but we've got it.
I remember that.
And like Peter Higgs, I'll give you something we'd lost, but we know that when Peter Higgs learned that they proved that Higgs particle existed, 50 years, 10,000 scientists, all this effort. He had a can of London Pride beer on the flight back from CERN in Geneva, and sadly he threw that can away, and we wished that he'd kept the can so we could have added that to the collection. So those sorts of things will be lost. So that's why we're doing it right now.
All right. You said that museums have this material culture, and this is the way you look at the world. But in the 21st century, we have much more information that is not tangible. How do you deal with that? Like, many things occur in the internet, and can you collect anything from that world, or how is that possible?
It's a great question, because it's something we're wrestling with right now. And you're absolutely right that, in fact, it's a sort of double whammy, because the first problem we've got is that if you look at science in the 20th century and the 21st century, a lot of it is to do with the worlds of the invisible. It could be the subatomic world, it could be CRISPR, gene editing and so on, molecular biology. It could be gravitational waves, looking at these violent events in the universe that send out ripples of space-time. Things around general relativity and quantum theory, really important, but they're, these are abstract concepts, very mathematical. So how do you collect those. That's one thing. But then on top of that, as you've alluded to, scientists now tend to manipulate big data sets. They work on workstations. They prototype things virtually. So we've got to capture that. So in fact, that's one of the things we're looking at right now is how do we capture, say, the first images of the virus down to atomic resolution, or there's been amazing work looking at the way anti-vax views spread across Facebook, which are kind of these huge, colorful network diagrams. So we're beginning to think about how do we collect digitally, store digitally, and display digitally as well.
I think the virus appeared in Europe early 2020, right? Or that's what we currently believe or we think. When did you start this COVID collecting project? Because I think it was very early at the beginning.
It was. I mean, I think the UK was quite quick in a couple of respects. I mean, on the Medical Research Council, we were funding quite major research projects right at the start of the year when we got the first reports. When it started looking serious from Wuhan. I can't remember exactly when our COVID collecting project started, but it was definitely in the spring sometime. So early on.
I think I read March on your website. Actually, I will put down the link to this project as well to the video description so people can find it there.
And then, personally, because I've got a background in writing, I started to write these slightly unusual blogs, which are, they're not narrative blogs, they're written as Q&As, maybe up to 4,000 or 5,000 words long. So what amazes was people would spend, half an hour reading them. And I've written 21 of them, and I'm actually starting to write them again, because I think with this kind of health crisis, I mean, as a journalist, I've only seen this happen a couple of times before. It's so serious that people have a huge appetite to understand the details of what the scientists understand.
What generates this appetite? Of course, from the social standpoint, I can understand because everyone meets the consequences of the virus and the handling of these pandemics. But as a museum, how do you see or how do you measure the change of the field of interest in the people? Do they send you emails? Do they request information in other ways, or how can you approach this?
We get all sorts of. I mean, obviously, we've got we've got our curators who keep an eye on this. There's me. I'm always scanning for subjects of interest, and we've got a big events program. We sometimes get ideas from that. Sometimes it's contingent on funding. People are interested in funding an exhibition about a certain area. We have a cancer exhibition under development, which we think is a really important area. It's lots of different ways. We also do a lot of audience research as well. So we break up our audience into 8 different categories. So we never think about the public as per se. We think about the audience as whether they're sort of hipsters. We give them these sort of rather arcane titles, but some of them could be a younger audience that want to have kind of cutting edge events. Some of them are traditionalists. So we've got one of our museums has got an enormous number of locomotives, Stephenson's rocket and the Flying Scots.
I'm so envious,
That's right. We have literally got a very big train set indeed. So we try to understand what the audiences want. And obviously we get insights from what the web audience are looking at in terms of our collections that are online.
You said you were quite quick in the UK responding to the virus in many ways, but we also know the news that in some other aspects you were not as quick as you should have been. Sorry for the criticism here. But do you feel that many times, at least this is my perception, that many times the general public perceives the threat of the virus, the seriousness of the virus and this whole pandemics through the actions that they meet? I'm not sure if this was clear or not, but if for example, a government somewhere in Europe says that, okay, from now on, there is the curfew act that you have to get home by midnight and you cannot leave your home by 5, which happens in Hungary today, people start to speculate that how dangerous this virus can be if it attacks people only during the night. And I think there is a different approach that scientists do than the average public. How can you handle this discrepancy?
It's really difficult. I mean, in one way, the UK was quick in commissioning research, and actually, we've done, I think, some of the best research on the planet. We've done some of the, in fact, I think the biggest drugs trials on the planet. So we found that some old-fashioned drugs like dexamethasone work. We've got a couple of very promising vaccines. We've done big studies of the genetics of the virus. We've also got the modelers. We've got some very good modeler teams. And I think it's where the science met public policy that things were not as quick. But of course, the politicians, to be fair to them, had to think about the enormous economic impact of things like lockdowns. And so, for example, we know that in March of this year, we had 3 separate modeling teams trying to look at different scenarios about how to keep the virus under control. And I think one problem was that the epidemic had got far further in the UK than we realized. But even so, the modelers were telling the government, you've only got one option, which is a lockdown. It took the government, I think, from something like the 11th or 12th of March, somewhere around there, until 10 days later to act. And when you've got a pandemic that is growing exponentially, that translated into a lot of deaths. So that was, regrettable. We've got a second lockdown now, and the scientists again were warning at the towards the end of September that we ought to have a short lockdown. It's taken longer to introduce it than we thought. But equally, it's quite tricky because I think we're more aware of the huge, devastating social and economic impact of a lockdown. And I think in a funny sort of way, politicians sort of don't believe the models until the evidence is overwhelming. And I think what worries them is this, that if you did a lockdown very early on, as the scientists could see the epidemic powering up, and let's say it worked and you kept the epidemic under control, you'd have people saying, you've just wasted billions of pounds and nothing happened. So
Hungary, I think, is the live example for that.
Yeah.
We barely had any cases in the spring. Yeah, absolutely. We got a reaction here. We got a reaction here explaining what this curfew act is really about. It's because the virus comes from bats, and bats are nocturnal animals, so this must be the reason. Well, I'm not sure if this is true, but thank you very much for this feedback. You said that you do audience research and you try to communicate accordingly, but of course your audience is made of people who are interested in science and who trust science to some degree. But what about skeptics? What about those who do not believe in the seriousness of the virus, or even think that this is just some conspiracy?
I think it's really difficult because I think there's a sort of a paradox which we've seen with climate change denial. We've seen it also with the moon landing hoax conspiracists and the flat earthers as well, which is in a strange way, when you confront these people, I mean,
I don't believe in flat earth. I think people who are flat earthers are not true flat earthers. I don't believe that.
Okay, the serious ones, obviously. I mean, the most relevant one to this is the anti-vaccination group. And the curious thing is that the more rational information you put in front of them saying, look, this works. I mean, if you talk to the World Health Organization, even before COVID, they call it vaccine hesitancy. They estimated a couple of million people were dying each year because they were not getting the vaccine. So we know this is, a serious issue. But the paradox is that when you confront anti-vaccination people with the facts, you seem to entrench their views. They just cherry pick the 3 out of 10 million facts that suit their hypothesis. And so it's about winning hearts as well as minds. And it's a very difficult thing to do.
Yes, but but we have to do it somehow, and I'm not sure what would be the proper tool to address those people, or just ignore them, or what should we do? Because if the majority believes that, or even political stakeholders believe that, then we are really in the middle of the chaos.
No, I agree with you, and I think with the virus, people have underplayed. It's complicated getting the infection death rate of the virus, and it depends where you measure it and which age group and all sorts of things. And people have made wild assumptions about how many people have been exposed to the virus. But, a common thing that's said is it's just like the flu. It's really not just like the flu. It's like 20, 25 times more deadly than the flu.
Even if you think of the flu, it was the Spanish flu back in the early 1900s, and it was just the flu, but it killed millions and millions of people.
Absolutely. And I think that what's pernicious about COVID, which we hadn't really thought about before, is that you've got a virus that actually can, you can be infected and you can be symptom free, and yet you can be infecting other people. And I think whenever people have thought about a pandemic virus, they've always thought that whoever comes into contact with the virus will be ill and they'll self-isolate and they'll be out of circulation. But this one, you've got a substantial number of people who are infected, who don't notice it particularly, who are spreading the virus around. And obviously, it could be younger people, for example, and then they meet an elderly person, and then you get problems. I think though the only way we can deal with this ultimately is to engage, with skeptics and engage with these issues. But it's got to be done in the right way, because I think you don't want to legitimize mad ideas. I mean, so to give you an example, we did on the Apollo moon landing anniversary have a big session about the many Apollo conspiracy theories, but the session was about why do people believe in completely irrational things. It was not to legitimize their theories, if you see what I mean.
Related to your work, you have to deal with COVID on a daily basis, but do you switch off occasionally, or do you feel that it's overwhelming sometimes to watch the news and check it all the time?
Yeah, I do have to switch off. You're right. It can be a bit relentless, actually. I think the combination of COVID and the American election have almost driven me mad.
Okay, sorry for bringing this up, but this is the title of the series. But how do you do that? I mean, can you get away from it? Because many people, of course, are very upset with the virus, upset with the policies that are brought because of the virus, and they want to get away just to calm down a bit. Do you have any suggestion for the people?
Yeah, I mean, you wouldn't believe it looking at me, but I do go for a morning run to clear my head, and I find that very helpful.
You also have this treadmill desk, right?
I've got a treadmill desk, that's right. In fact, Laszlo, when normality returns, if you're back in the UK, you are welcome to take my treadmill desk for a spin, okay?
So you say I could join the team of Craig Venter, who was also in your office once. And, oh my God, that was the best invitation I've ever got.
Yeah, I've only had a couple of refusals, actually. Lord Grade, who's a kind of media mogul, I think he quoted someone like Oscar Wilde and said, Roger, every time I think about exercise, I lie down until the thought passes away. And then Tim Berners-Lee, the inventor of the World Wide Web, was in my office. And you could see him thinking, has he just asked me to go on a treadmill desk? That can't really be right. So I'm just going to ignore it. So he just completely ignored me. But most people think it's quite funny. So
okay,
exercise is a good thing. I think turning off the news for a bit is definitely good. A good Netflix or box set or something, and Zoom calls with your old friends with a big glass of wine in front of both of you. I think that's another recipe for contentment.
Okay, but when you are back to work and you have to view all the data and everything, what fascinates you really in this virus? Because there has to be some fascination, otherwise you wouldn't do that, or you must be driven.
No, I find it fascinating on so many levels. In fact, I mean, today I've talked to two scientists who are really at the leading edge. So one of them is Neil Ferguson, who did the really some of the big computer models that suggested the lockdown and the way that the epidemic would spread. And it was fascinating talking to him about the details of how do they set up the models, and they come in different varieties. And how do you make sure that your model, when it's looking into the future, is giving you the right results? So that was interesting. And then another researcher, Chris Chew, I've just talked to about the UK doing the world's first COVID challenge trials, where they're going to grow the COVID virus in a special facility. They're going to pick young people without risk factors, and they're going to infect them with COVID, so they can first get a very detailed picture of what it does to the immune system, and also they can get a very detailed picture of how well vaccines work. So these are ethically difficult things to do, and again, it's another very fascinating area.
Yeah, ethical questions are always very fascinating to me as well in science, and there are so many.
Yeah.
And you discuss many ethical questions in your books as well. And this is a very good translation to another topic that we talked about that we should touch. Is your new book is coming out. What will be that about?
That's right. It's The Dance of Life with Magda Zernicka-Gertz, who's a developmental biologist. In fact, look, here's a copy of it right here. And I didn't pay for a product placement, Laszlo. Forgive me. But
that's all right.
But Magda
we'll have to set this deal with the British Embassy here in Budapest. But I think they are okay with that. We are spreading British culture, so.
But Magda studies absolutely the first week or two of development, doing most of her studies on mice, but actually she does study human embryos under very specific examples.
Talking about ethical questions.
Yeah, well, that's obviously huge. Where do you get human embryos from? And obviously they're using surplus IVF embryos with the permission of the parents and for very defined problems. So, for example, just recently, she's been looking at whether the human embryo would be susceptible to COVID. And in fact, she does these studies where she can label gene activity through clever fluorescent probes in the early embryo. And they found that the use of certain genes, one called ACE2, which actually helps the virus invade cells, suggests that COVID could potentially be active in embryos as early as the second week in pregnancy. So that's something to be aware of, and so on. But she's also done even more extraordinary research, because you obviously, to make an embryo, you have an egg and you have a sperm. But in fact, the very early embryo consists of 3 so-called stem cell types. These have got the potential to grow into all the cell types in the body. And Magda has built artificial embryos just from stem cells. So there's no eggs and sperm involved, and watch them develop in the laboratory. You can do different sorts of
that raises many ethical and moral questions as well. Sure, if you have no parents, or you have basically just one parent, and but we somehow saw this with Dolly when the first sheep came to life. That was very interesting, and you even wrote a book on that.
That's right. With Ian Wilmer, and I did meet the late great Dolly several times. She was quite a big sheep, because I think they kept on feeding her treats, and she would always rush up, sort of bleating, demanding food if you walked into her pen. This is in the Roslin Institute.
I met Dolly posthumously because she was stuffed and toured around Europe, as far as I know, and for a year it was in our science center here in Budapest. So when you enter the building, you face Dolly sitting there, not sitting, but standing there, in a box. So
I mean, but what amazes me is how quickly science changes. So we talked about therapeutic cloning. So how could you grow replacement cells for your organs, and you would you'd have to take your DNA and reprogram an egg cell, and the embryo would grow, and then you'd dismantle it and grow these cells into different cell types. But of course, an amazing Yamanaka in Japan in the mid-noughties found a way to genetically reprogram, say, a skin cell and turn it into an embryonic cell. So we don't have to think about therapeutic cloning anymore for creating tissues to test drugs and so on. So it always amazes me in science how something can absolutely change everything. People don't talk that much about cloning nowadays compared with, say, 15, 20 years ago.
I'm sure it will come back because there are these buzzwords, that are trending now and trending later on. And cultural industry, like film industry, can play a huge role in that. But I'm not sure here which affects what. Like when Gattaca came out, everything was about cloning, but I'm not sure if it was preceded by the great scientific breakthroughs, and then came the movie.
No, well, you're right. There's always an interesting. In fact, we're looking at one of the long-term projects we've got is looking at the relationship between science fiction and science fact. And if you look at the early space pioneers in Russia, they were very influenced by science fiction by Jules Verne. People like Tsiolkovsky. He's like the father of Soviet space exploration. And there was the cosmist movement that were fascinated about colonizing other planets. All this was happening at the turn of the 20th century. So while the Americans were conquering the Wild West, there's a huge number of Russian intellectuals thinking about conquering space. So that's why the Russians really won the race into space. There was so much appetite and interest from a long time.
That's a very interesting view. What I could think of that, when you are writing these science fiction novels or screenplays for movies, you're playing with these ethical questions that will come to our mind later on. So if you think of pandemics, if you think of how to shut down a whole city, there were plenty and plenty of science fiction movies before discussing this issue, and now we are living it. But it's still different somehow because we are not in the cinema, of course.
No, and I think actually science fiction's got a fascinating role to play because it can help you. If you look at something like Blade Runner, that was looking at what does it mean to be human. When you look at Total Recall, again, another Philip K. Dick book was behind that. That was all about memory and how your identity depends on your memory and your recollections. So I think science fiction is a wonderful way to explore where this great adventure called science is taking us, and also air the ethics, in a way before we actually have to encounter the reality.
Oh, I got this comment here and then science makes science fiction boring. I love the 60s sci-fi novels more.
Well, I must admit,
we can see it this way.
Well, everyone's got their favorite, vintage, of science fiction. But I have to admit, I think certainly on TV, British TV, with things like Doctor Who, and when we used to get Star Trek and so on, that I know what they mean about the 60s being a golden age. I think it was.
Yeah, I'm just reading comments that arrive. I'm not sure if we can answer these questions. Some of them are not related to today's topic, so we are not the experts for that. But we continue this COVID conversation series with medical experts next week and the week after. So maybe we can answer some of these questions.
Yeah, well, fire away. Let me see how I can get on. All I can do is look stupid and ignorant.
Yes, all right. I try to translate it on the go that the protocol changes from hospital to hospital, how you treat COVID positive mothers in the maternity ward. There are some people where they separate mother and child. I guess this is what is about. And there are some other wards where mothers and children are together. What do you think would be the best process or protocol to follow? Or I would just say from a scientist standpoint that now we have a perfect sampling and randomized sampling, that in some wards we have mothers together, in some wards not, and we can see what happens. But that also raises some ethical questions.
Yeah, I think the impact on COVID on the young, it's something that the risks grow very steeply the older you get. So to me, separating mother and newborn baby sounds a bit radical. So I'd be interested to know what the evidence of the need. Being a scientist, I really want to understand why they felt they'd had to take that step.
But it's also a very interesting question, because now we probably have, I'm not sure, but probably we don't have enough information at the moment. But this way we can gather more and more scientific clues for making decisions later on. And this is how protocols are developed.
Well, I think the thing, you can either look at things as sort of in an optimistic way or a pessimistic way. The optimistic way is that, it's less than a year, and we've learned an enormous amount about the virus. Another thing that fascinates me is all the detailed molecular biology studies of how it latches onto human cells and how it spills its genetic code into our cells and reprograms them and so on. It's such a simple thing. You and I have got a genetic code that's 6 billion letters long. The viral genetic code is like 30,000 letters long. It's 29 genes. It's more like a clever chemical than a living thing. So I find all those kind of details fascinating. And we found a lot of those details. We've got amazing molecular atomic pictures of the virus now. And, it's called coronavirus because of this haze of spikes around it. But on the other side, there's still some really big questions we don't quite understand. So, in the last couple of weeks, we've had one British study looking at how many people had antibodies in the population and finding that it's been dropping quite a lot, which means that, the protection from coronavirus, if it only depends on antibodies, because there are cellular bits of the immune system, that would be bad news. It wouldn't last that long, and maybe a vaccine protection wouldn't last that long. But then another study, which was using different methods, suggested that antibody protection lasted quite a long time. And it's difficult in science. It depends on the design of the study and the statistical power of the study. And it can take, a year or two to sort out these quite big issues. So to go back to the baby in the wards question, we probably still haven't got quite enough information to decide the right thing to do.
That was a very interesting perspective that you brought in here, because I think the press is not too good at balancing the value of the information. So whenever there is a new research result comes out, they are happy to put it on the headlines. And it doesn't go through the standard scientific process to discuss and validate information in big depth. But I'm not sure, based on this question, how you approach this at the Science Museum. Like, how do you decide what to include and what not based on the scientific accuracy? I feel that you are somewhere in between the proper scientific community and sorry for this that I called it like this, but and the general public or the press.
Well, I worked in a busy newsroom for 22 years, and you had, and I'm not exaggerating, you had like 10 seconds to get the attention of the news editor. They're looking at screens. My old news editor used to have 2 screens in front of him or her and a huge bank of TV feeds. So they're seeing hundreds of stories. So when you're a science journalist, you're trying to come up with the most impactful angle that gets their attention. In fact, I used to joke, the less explaining you could do and the fewer words you use, the more success you had. In fact, the shortest pitch I had to get a story in half a page of the newspaper in 22 years was 2 words. I said to the news editor, penguin prostitution. And he said, yeah, you can have half a page. So that's great. But the problem with that system is it makes you hype everything up. This, by the way, in case you're wondering what on earth is penguin prostitution about, it was about
you know what my question would have been, right?
rocks, to make nests and so on. And it was in a proper scientific journal. As a great example where very arcane science can be deeply fascinating. But you're absolutely right. The problem with this headline-driven approach, where you're trying to push, war and murder and all these other headlines out of the paper, is you tend to overdo it. So it's quite difficult to be balanced. Equally, if you're too balanced and you give too much information, it's so boring, no one's going to read it. So, what's the best way to do it? It's a tricky one to get the balance right.
Absolutely. But if we are talking about balance, now everything is about COVID. I don't want to quote a big nation's president saying COVID, COVID, COVID everywhere, but he is somewhat right. And we tend to forget about other issues like climate change and other very, very threatening issues. How can you try to find the balance as an institution in this scope?
Well, newspapers have got a very simple agenda, which is at the end of the day, they want to attract eyeballs. So, what the reader wants to read about, that's what you try and provide. And sadly, if they want rubbish and speculation that's more entertainment than fact, these are, tends to be more the tabloid or the red top, as we call them, newspapers. That's what you provide. And then the Telegraph, certainly when I worked for it, was a more serious newspaper. For a museum, I think we do feel a greater sense of responsibility. And say with something like the BBC, as a public service broadcaster, they feel more of a responsibility to get the balance right and so on. But it's very difficult. And I think you put your finger on it.
What if you try to put a balance here? What if you try to put a balance here, but the audience is not interested? I think it's also a waste of your resources, if I can put it this way, that you set up an exhibition or you set up a huge communication on one field that you feel is very important and would be very balanced, but people are not interested in that because their brain is fulfilled with other information and they are interested in those topics much more. Actually, I don't want to name that exhibition and that museum, but I remember that there was a very badly designed exhibition from the audience's standpoint. And I know there were lots and lots of thousands of euros put in that exhibition and many, many work hours. And when that specific museum opened its doors, I can tell it to you after the after the show, there were hardly anyone visiting it, and it was so hard.
Well, let me tell you. I mean, when I used to edit a news science magazine called New Scientist, and we used to do audience research to understand the subjects that people wanted to read about, and climate change was really fascinating. Because if you ask people a very general question, the New Scientist audience was a very smart, savvy audience. If you said, "What are you concerned about climate change?" 99% were concerned about it. Are you interested in climate change? 99% were interested. If I put a climate change story on the cover of New Scientist, I would lose a third of my readership. That was a huge, painful. So the publisher would haul me in and tell me off
unless
for losing
you demonstrated
money.
With penguin prostitution.
Well, penguin prostitution, I suspect we would have done better than my climate change cover. But then we started doing some more research to understand how could people say they were interested in climate change and yet not want to read about it? What was going on there? And what we found was that I'm trying to remember the titles we tried out, because obviously selling a magazine just depends getting the cover art right and getting just a handful of words on the cover absolutely right. So in one headline on the cover, it was something like climate change, everything you wanted to know. And they were bored by that because they thought, well, I know everything about climate change anyway. Then we had another climate change headline that said something like climate change, apocalypse 2030, talking about some of the terrible things are going to happen if climate change gets out of control. And that did okay. People were quite interested. But then the headline that really got people interested was climate change, everything we know and everything we don't know. Now, for our audience, they really wanted to know what they didn't know. And it was beyond interesting. It was intriguing. And that's the word you're looking for. So you're right. You've got to be careful to pick the right subject, but also you've got to pick the right angle, the right treatment, the right hook to get people interested. So it's not just a matter of saying this area of science is interesting. It's like, what narrative are you going to take people through this area? And sometimes you can take quite a boring area, but find an interesting angle. So I think that's the secret.
Now you are doing this COVID collection or collecting COVID project at the Science Museum. Sure, it will be in your museum collections for I don't know, a few years, and then you will make an exhibition. Forever, yeah. Yes, of course, but it will probably not be seen by the public immediately, because if the pandemic is over, people, I'm sure, will not want to see many things about COVID for at least a while. What is your idea? When can you present it to the public? When we are at the right distance in the future from current situations? Like, what gives the value of this exhibition?
You know, I think you've raised a really a tricky problem there for us, because it really helps a collecting project if you have a specific exhibition idea in mind. I have to say, although it's very early days at the moment, we think that clearly there are huge impacts on society, many depressing in terms of the effects on certain communities and the economic impact and so on. But there is an optimistic story there about vaccine development. So we certainly think that although we might have to wait for the dust to settle, as it were, before we do a big COVID exhibition, in the shorter term, we're interested in looking at vaccine development, because we think that's a really is a great example of science impacting society. We've got collections that go all the way back to Edward Jenner and cowpox, and we've got little ivory tools that Jenner used hundreds of years ago to inoculate people. We also know that even
I can imagine the pus at the end of that little inoculation needle.
Exactly. And also at that
maybe
time,
I shouldn't have thought of that.
No, there were strong anti-vaccination views at the time. So this is something that's been out there. It's not a modern phenomenon at all. So we think this is actually a more optimistic take on COVID that people would be interested in finding out more about. So that I've probably given away our secrets now to all our rival science museums across the planet. I hope they're not watching.
Is there a rivalry between science museums?
We're kind of...
Of course, you have to say there isn't, but...
We're kind of friendly rivals. I mean, next door, there is the magnificent Natural History Museum. And obviously, they're a different sort of museum from us. They are a science museum, but they focus, obviously, on, fossils and dinosaurs. So we've always had this jokey rivalry that, you've got your dinosaurs and T-Rex, but we've got robots, okay? We've got artificial intelligence and things like that.
And viruses.
Viruses. Well, they've got viruses. In fact, we're both interested in viruses.
So if I put it right, they have the large things and you have the almost invisible tiny things. Great.
Yeah, well, we can give you giant robots if you want as well. Come on, we're not going to be beaten by a few dinosaurs. But obviously, you've got the Smithsonian in the States and the American Museum of Natural History, and when you look at space museums, the ones owned by the Russians and the Americans, they're astonishing in terms of the hardware that the countries have produced to get into orbit and so on.
I was astonished when you said you had over 3 million visitors a year. So for me, that's a giant museum, what you have. So
yeah, well, in fact, over the whole group, we got 5.5 million a year. Although this year, sadly, we're not going to have anything like that number. Yeah, but no, you're right. It's we've got a big impact.
Okay, so based on your impact, what do you feel when this pandemics will be over in a sense when you can see the light at the end of the tunnel?
Oh, it's such a tricky
With the
one.
vaccination, or it's even past that? You don't have to give me an exact date, but
I'm hoping there'll be a vaccine around. We've already got 6 that are approved for limited use. In fact, it's quite surprising, really, when you look at. I was a reporter for decades. I've never seen such a colossal scientific response. So we've got 50 vaccines in clinical trials. We've got 11 in large-scale efficacy trials. We've got 6 approved for limited use. So I think there's a good chance the first half of next year there will be some sort of vaccine with some kind of protection being distributed. But then there are complicated questions about, would it be like a flu vaccine where you need another injection in a year's time? We don't really know. Will this vaccine stop you from passing on the disease, or will it just protect you and not protect other people? So there is still a chance that COVID will be sort of endemic and out there and a nuisance for years to come. But I'm hoping that by the end of next year, with a vaccine, things will look a bit rosier and more optimistic.
Well, let's hope that. And there is a comment here that why would you put space in museums? I got this. So I wish you can fill up those spaces in the museum with lots of COVID-related objects, so you can keep. Thank you very much for being here tonight. It was a great pleasure to chat with you, and we will, of course, continue this series next week at the same time. We will focus more on the health issues of the virus at that time. Thank you very much, Roger, for sharing your stories with us.
It's been great fun talking to you, so thank you.
Thank you to the audience as well. So bye for today.